Algebra 2, Chapter 5, Section 4, Equations for Planes in the Line. So from up to this point, we have conceptualized linear functions while graphing. Okay, so in other words, a linear function, we've thought of a line as a function when we've been graphing. Instead, let's think about this equation again, y equals mx plus b. So instead of thinking of a function, so instead of thinking f of x is mx plus b, and remember a function has to have exactly one output, right? So instead of thinking of a function, think of this as an equation in two variables, y and x. Okay, so in other words, y and x are both allowed to vary freely. If we think about the set of solutions that such an equation would have, it would form the coordinates, it would form the points which would form the coordinates of a line in the xy plane. Okay, and you can find this by plugging in different values of x or y and finding the corresponding value of the other variable, given a particular m and b. And note that some of the possible lines that we can express with this equation cannot be represented as functions of x. And that's because there's a case where you would end up with what couldn't be a function because you'd have infinite outputs for one input. So for any constant k, so let's talk about the cases here of lines. So we have a plane, an xy plane with these coordinates perpendicular, x and y coordinates. If we have just a line that slopes like this, kind of like what we've talked about already, we see the slope m. Okay, and we can write the equation y equals mx plus b. B is the y-intercept. It's the y value where the blue line touches the y-axis. Okay? What if we wanted to graph a horizontal line? A horizontal line would be a line parallel to the x-axis. Okay? The equation for a horizontal line is just y equals k. There's no x, because it doesn't matter what x is, the value of y is the same. And k is going to be the number that the number that y always is. So if k is 2, you have a line that's going through the y-axis at y2. If k is 7, it goes through the y-axis at 7. If k is negative 3, it goes through the y-axis at negative 3. Now, the slope in such a case, m is 0. There's no slope, right? M is 0, and you can see that this is k, and the k is actually just equal to b, the y-intercept. So that this case still fits into thinking of it as a linear function, but thinking of the second case, it does not. So if we think of a vertical line, can be expressed as an equation x equals k, some constant. And the constant will be where the line goes through the x-axis. So if it's 3, then the line would go through the x equals 3. If it were negative 2, it would go through x equals negative 2. In this case, the slope is undefined. It has no definition because the run is 0. Rise over run, remember? Or the rate of change. Change in y over change in x. This line isn't changing in x at all. So there's no slope. The slope is undefined. And this is the case where we cannot write this line as a function of x, because it is not. It's a function of y, but we haven't thought of it that way. Since we can't form vertical lines in point-intercept form or point-slope form, in slope-intercept form or point-slope form, either one, we have a third form for a linear equation called the standard form. Standard form. In standard form, we write the equation like this: a times x plus b times y equals C. And A and B and C are all constants. Again, this is similar to point slope form in the fact that one line can have many different representations of A, B, and C. So if you get, and you can see this, if you could just multiply this equation by 2, and you would have different A, B, and C, but the same equation in terms of the graph. The line would be the same. You would end up with an equivalent equation. So let's write the values of A, B, and C in the standard form of a linear equation. And like I said, these aren't unique. Okay, for a linear equation for the following equation of lines. So here we have, if you think about A was the coefficient of x, B is the coefficient of y, and C is this constant we're on the right hand side with nothing multiplied by. So A would be 0 in this case because x, there is no x. B would be 1 because y has no coefficient. And C is for part A. Part B, we have A is 1 because there's an x and it has no explicit coefficient, so its coefficient is 1. B is 0 because there's no y, and C is minus 3 because it's the right hand side. For part C, now we need to rearrange, so we need to move the 2x over. Minus 2x plus y is minus 1. So A is minus 2, B is 1, and C is minus 1. Now if you had rearranged it differently, you would end up with a different A, B, and C, which is still a right answer. For instance, for part C, if you'd moved y over and had 2x minus y and moved minus 1 over, is 1. And you'd written down A is 2, B is minus 1, and C is 1. That forms an equivalent equation to the equation this one forms in standard form, because this is just negative 1 times all those coefficients. Part D, we have A is 2, B is minus 1, and C is 1. Find the axis-intercepts of the line 5x plus 4y is 20 and graph the line. Okay, so the axis-intercept. So what value does x have when y is 0? That'll tell us the x-intercept, because the x-axis is where y is 0. Maybe this would be best if we go ahead and draw our lines for graphing using a ruler. Now we have to think about, here's x, here's y. So when y is 0, when y has a value of 0, that is when we'll touch the x-axis. So if we solve this equation, 5x plus 4y is 0 equals 20, this part goes away. We just need to know what is x here. 5x is 20, x is 4. Okay, so the x-intercept will be at 4. So you make a yellow line. Yellow's hard to see. Pink. Magenta. Okay, so here's the x-intercept. The y-intercept will be when x is 0. Plus 4y is 20. So y dividing, this is 0, so dividing by 4y is 5. So if we mark 1, 2, 3, 4, 5, or if you have graph paper, you can just go up 5. Those are our two intercepts. Okay, so to graph the line, all we need to do is use a ruler to join these 2 points. Okay? With the ruler, we can go through and beyond without any trouble to make a nice straight line. So here's an idea about parallel lines and perpendicular lines with the slopes. So if we think back about the cases. There was these three cases. There's the case where the lines cross with the linear equations, and then there was a case where there was no solutions when the lines are parallel, right? So it might be interesting to know what kind of slopes we have for parallel and perpendicular. So the lines, if you have two lines and they have slopes m1 and m2, the lines are parallel if and only if the slopes are equal. Okay, so the slopes are equal if and only if the lines are parallel. The lines are perpendicular if and only if the slopes are negative reciprocals. So m1 would be negative 1 over m2, and m2 would be negative 1 over m1, if and only if the lines are perpendicular. So we can use this to find equations for lines that are parallel or perpendicular. So let's do some examples. A. Find an equation for the line parallel to the graph y is 12 minus 3x with the y-intercept of 7. Okay, so let's think about this. This graph has a slope of minus 3. Okay, so we need to find an equation parallel to this, which means that our new equation for the new line will have a slope of minus 3 and a y-intercept of 7. So we already have the information we need to form an answer. B. Parallel to the graph 5x plus 3y is minus 6 with the point going through the point, or the line has the point 9, 4. So x is 9, y is 4. Okay, it didn't say what form the equation has to be in. First, let's find what's the slope of this line here that we need to be parallel to. So if we think about that for a minute, we need to solve for y to find the slope, because this is in standard form. We need this in slope-intercept form. So solving for y, we'd have 3y is minus 6 minus 5x. Dividing by 3, we'd have minus 2 minus 5/3 x. So the slope of this line is minus 5/3. That's what we're interested in. So now we can write y equals slope minus 5/3, and we can use point slope form. So x minus 9, that's our x naught, is 9, plus 4. And we're done. We don't have to write it in slope-intercept form. It didn't say so. It just says find an equation for the line. C. Find a line perpendicular to the graph of y is 5x minus 20 with an x-intercept of 6. Okay, so a couple things here. X-intercept of 6 means the point 6, 0. The y value is 0. So we can use point slope form to find the equation quickly. We just need to know the slope of this new line. Well, now it's perpendicular. So negative reciprocal. So 5 reciprocated is 1/5. Negative is negative 1/5. That's the slope of the perpendicular line. So y equals minus 1/5 x minus x naught plus y naught, but y naught 0. Okay, so we're done. This is not as hard as it seems. D. Perpendicular to the graph of y equals 3 going through 2 minus 3. Well, the slope of the graph of y equals 3 is 0. We can't reciprocate 0. A line perpendicular to this horizontal line would be vertical. Okay, so we might be tempted to write no such answer, but that would be wrong. We just can't use the negative reciprocal to find the slope. But we can use geometry to think about the line that's perpendicular. So let's draw a graph to help us with this one. For part D, we have a line y equals 3. Okay, so it's a horizontal line where y equals 3. Oopsie. Don't need a ruler there. Y equals 3 is the blue line. And we need to want it to go through the point 2 minus 3. Okay, this new line wants to go, this is 1, 2, 3. 1, 2, minus 1, 2, 3. So our new line needs to be perpendicular to the blue line and go through the black dot. Okay, so using a ruler, draw such a line. Okay, and if we think about the equation of this line, would have to be x equals a constant, and the constant would have to be 2 to go through that point 2 minus 3. So the equation for this line is x equals 2. Okay? So it's the hard case. The hard case is when you have to go perpendicular to a horizontal line, because you can't just use slope-intercept form or point-slope form. You have to use the equations where we learned horizontal and vertical lines. E, parallel to the line in B, but passing through the origin. So in B we had a slope of minus 5/3. For its pass through the origin, that means it has an x-intercept of 0 and a y-intercept of 0. In other words, all we need to write is y equals minus 5/3 x. We're done for part E. Okay? You could think about it as point-slope form. The point would be 0, 0, x naught would be 0, and y naught would be 0, and you end up with minus 5/3 x. Perpendicular to the line in B, and going through the origin. So the slope here was minus 5/3, so the negative reciprocal would be 3/5. Negative reciprocal would be 3/5 x. So going through the origin, there's no y-intercept, no x-intercept. We're done. So that's our answer to F.